Hello everyone. In this video, we will talk about everyday usage of linear graphs. Now we have seen many situations. Let's talk about when we go to purchase fruits. So one apple costs, let's say 40 rupees. How much will it cost for 5 apples? Obviously 1 is 40, so 2 is 80, 3 is 120, and that way it will cost rupees 200. 5 apples will cost rupees 200. Now here we see that the amount is increasing as we increase the number of apples. And in such cases, this first quantity is represented as a variable, and that variable is called as independent variable. Why is that independent? Because it does not, we decide how many apples we want to buy. So we increase, we change the numbers here. So this is not dependent on anything else. This is independent, or it is also called as control variable. Whereas the amount here, what we got, when it is represented by a variable, this is a dependent variable because it depends upon how many apples you want to buy. If you want to buy 5 apples, it is 200. 1 apple, it is 40. 10 apples, it will be 400 rupees. So the value of this variable, because it's varying, it's changing, value of this amount variable is dependent on this variable number of apples. And so it is called dependent variable. This one we change, this one is driven by whatever we make changes here. So this is dependent, this is independent. We'll solve a few examples and try to understand or try to find which one of them is dependent and which one is independent variable in those sums. Let's do that. Draw the graphs for the following tables of values with suitable scales on the axis. Number of apples and cost in rupees. So we have number of apples, we'll show number of apples on x-axis. And on our y-axis, we will show the cost in rupees. This is cost in rupees. To draw the graph, we will have to plot the points. The number of apples was 1, that time cost of was 5 rupees. So 1 here and cost was 5 rupees. So 5. So this is 1 point. When it was 2, cost was 10 rupees. 3, 15. 4, 20. And 5, 25. So now we have plotted the points. We need to connect these points. So let's do that. And we see that when we connect these points, we actually get an unbroken line. And hence this is a linear graph. Now we see here, number of apples is the independent variable or the control variable. And the cost is a dependent variable. And that's why we have put the number of apples along the x-axis and the cost along the y-axis. This is just a standard which we follow. Let's do one more. So we want to draw a graph for time in hours and distance traveled. So at 6 a.m. I have reached 40 kilometers. At 7 a.m. 80. At 8 a.m. 120. At 9 a.m. 160. So here it seems that time is the control variable because time is going to increase without, it's not depending on anything, it will increase. The distance I travel is dependent on the time because as time passes, the distance is increasing. So we'll plot along the x-axis the time in hours. So it is 6 a.m. And along the y-axis, we will write the distance traveled. And the scale which we are using is 1 unit is 20 kilometers. Let's now draw the graph, and for that let's plot the points. At 6 AM it is 40 kilometers, so it is here. At 7 AM it is 80 kilometers. At 8 AM it is 120 kilometers. At 9 AM it is 160 kilometers. From the looks of it, it looks like when we join these points, it's going to give us a line. Let's see if that happens. And yes, when we join these points, we see that there is a line, unbroken line. And hence it is a linear graph. We know time is the control variable and distance is the dependent variable. Let's draw one more graph. The graph shows the deposit and the simple interest earned on that deposit. Now if you see the deposit, as the deposit increases, the simple interest is increasing. So deposit is your control variable and simple interest is the dependent variable. Let's plot deposit along the x-axis. This is deposit along the x-axis, and along the y-axis we will draw the interest. So it is SI here, simple interest, and that is also in rupees. And now to draw the graph, we will plot the points. For 1000 rupees of deposit, we had simple interest of 80 rupees. And so that point comes here. For 2000, we had simple interest of 160 rupees. For 3000, it was 240. For 4000, it was 320. And for 5000, it was 400. Let's join these points. And we see that it is a linear graph because it is an unbroken line. And now let's answer these questions. First, does the graph pass through the origin? Yes, the graph passes through the origin. The answer is yes. Use the graph to find interest on rupees 2500 for a year. So 2500, where it will come? Deposit of 2000 is here, 3000 is here, so 2500 is here. So if we travel up, where do we intersect? We intersect at this point. And we see that that is SI of 200. So SI would be rupees 200. To gain an interest of rupees 280, how much money should be deposited? So we'll travel here on 280. We'll travel horizontally and see where we touch the point. We touch it here and we see that the deposit was 3500 rupees. So if we put a deposit of rupees 3500, we'll get interest of 280. So if we see in a linear graph, it will be easy for us to even find the entries which are not recorded. So we have not recorded anything about 2500 deposit or 3500 deposit or the interest of 260. We can extrapolate, we can find out when we will get interest of 360 by using the linear graph. So linear graph is not only useful for the information which is presented there, but it is also used to find the unknown information. I am sure you have liked the video. Hit the like button and leave your views in the comment section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the YouTube app at the link provided in the video description. Till we meet again, goodbye.